Good evening, everybody, and welcome to ECE 442. I'm glad all are safe and healthy. Let's continue our discussion on the memory, try to wrap up the material on the memory. The last thing we did before the midterm, which by the way, I haven't even brought it up from the trunk of my car, which means what? It's still in the trunk of my car. After Thanksgiving, after I eat too much, then I will sit down and create something. Oh, so don't rush me here. One more time. We started talking about the DRAM, which is the dynamic RAM, and we said the beauty of the dynamic RAM is that all what we need is how many cells? Only one cell, which means what? One cell, how many I said how many cells, I'm sorry. How many transistors do we need? Only one transistor per what? Per cell, as compared to what? 60, which is the what? Which is the SRAM. Clear? Which is the static RAM. Of course, the static RAM is superior to this one. Clear? But this one is appealing for some situations that requires what? Very small area. Clear? Very small area. This. So let's review it very quickly. We went through this last time. Let's review it very quickly. We do have the word line. This is the word line. Where is this one coming, by the way? This is coming at the output of the raw decoder. Remember the raw decoder? Yep. Which means what? What are the inputs to the raw decoder? What are the inputs to the raw decoder? Is the what? Address? Yes? Yes? Address of what? Whichever row you want to what? Activate. The output is the what? Is the word line. Clear? Okay. Then we do have the bit line. Again, one more time. Is there a connection here? No. No connection. Don't get confused. When you see a connection, it means what? It means that it has to be a bold dot or something. Clear? Bit line, where it is coming from? Output of the column decoder. And what do you notice? You notice that we have only what? One bit line. We don't have a what? Bit line and bit line what? But we only have one bit line. Now we will see in a minute what do we do for this and when we design our sensor amplifier. Remember one more time, a sensor amplifier for a DRAM is a necessity. And it's not a luxury. Do you understand what that means? It's a necessity for the DRAM to work. You need to use a what? A sensor amplifier. Whereas the SRAM, you only need to what? You only use a sensor amplifier to speed things up. Did you get it or not? Yep. But it's not what? It's not a necessity. You could do without it. Clear? Okay, as we will see in just a second. We do have a storage capacitor. This is not parasitic. Did you get it or not? Yep. This is an external capacitor. This capacitor, on the other hand, the bit line capacitor is a what? Is parasitic. Did you get it or not? It's parasitic. This one is we call it what? The storage capacitor. The storage capacitor. Clear? Now, let's see how it works. Start with the what? What did he start? Okay, so he's starting with the what? Let's start with the write. Clear? Suppose I want to write something into the memory. First of all, answer me the following question. Does it matter what is the current bit? No. When you write something, you are overwriting whatever there is. So if there is a 1 and you write a 1, then it means what? There will be no change. But if it is a 0 and you want to write a 1, you are overwrite. Did you get it or not? Oh, good. So, bit line and word line. What are the steps? So we are talking about what? The write operation. Assume. A 1. Yes? Right 1 means what? Means I want the voltage across this capacitor to be equal to what? 1. Oh, what is the steps?
Line charge.
Pre-charge. Bit line. To what? VDD. Yes? Number 2, assert the word line. Assert means what? Choose the address of that word line. By the way, are there other cells in here? Are there other cells in here?
Yes.
How many in each row? Depends on the size of the memory. Yes? Are there cells in here? Yes, they are. Depends on what? Depends on how many words in there. The first one depends on how many bits per word. Clear? Good. So what will happen? Assert the transistor is on. Yes? What can you tell me about the NMOS? This NMOS passes a what? A weak one, which means what? The voltage.
Thanks.
Agree?
Yeah.
No response. Agree?
Yes.
Yep.
Question. Do we have body effect?
Yes.
Yes, we do have body effect. Why? The current will go this way. Which means what? This is the drain, this is the source. Did you get it? Okay. With body effect. How did they solve this problem? Is this a problem?
Yes. Yes.
Is this a problem?
Yes.
You are not storing a what? A strong one. Yes?
Yes.
What did I tell you they did? They what? This word line, they boost it up, and instead of VDD, they make it what? VDD plus VT. So that when you subtract VT, you end up with what? VDD. Did you get it?
Yeah.
How do you do that? How do you do that? Look at your raw decoder. Do you see the raw decoder? What did we say? We say we pre-charge the PMOS in the chart. Didn't I pass to you chart? The original chart. No, you did not bring it with you. I did not pass chart for you for this one. No. Yeah, this one. Do you see the PMOS? Let me show it to you.
Yeah.
That's a raw decoder. Do you see this one? Yes? Remember how it works. We pre-charge all of what? All the word line to what? 1. Yes? Which means what? To VDD. And then what? Only the row that I want to what? Select. I keep it what? VDD. All the others I bring it to what? To the ground. And instead of using VDD here, they use what? VDD plus VT. Did you get it? Yes or no? Which means what? They increase a little bit the what? The drain voltage of the what? Of the PMOS. Did you get it? And remember, the PMOS passes a what? A strong one. A strong one. So when you put this one, this one will be the same voltage as this one. Did you get it?
Yep.
Good. This is the right operation. Yes? Yes? Now read operation. Ouch. characteristic of the DRAM. Recall, DRAM is destructive. Is that good or bad?
Bad.
Bad. Which means what? While it is reading, it is what? Destroying the what? The content of the memory. How did we find solution to this? After you read it, and the sensor amplifier, what? Amplify it, you what? Write it again. Which means what? You take this bit and put it on the what? On the bit line. Follow the write operation.
Yeah.
Did you get it? Periodically. You need to do that periodically. Refresh it. Clear? Okay, good. How does it work? Assert, pre-charge, bit line to VDD over 2. Yes, I will show you how we do that in just a second. Pre-charge the BLL, the BL, the bit line to VDD over 2. Yes? Now, if this tone is a 1, yes? If this stored bit is a 1, what will happen? What will happen is that the charge will be transferred from the CS to what? To the CB until the voltage between them are what? Equal. Why? Because they are in parallel. Yes or no?
Yeah.
Notice, by the way, what am I neglecting here? I'm neglecting the resistance of this one. You follow? This is switch. This acting as a switch. You follow me or not?
Yeah.
Yes or no? The switch has a small resistance in it. We are neglecting it. Yes? Which means
Yeah.
what? The voltage on this line will go what? A little bit higher than what? VDD over 2? Yes?
Yes.
Now suppose what is being stored is a 0. What will happen? The current will go the other way around, this way. What does it mean? What does it mean? The voltage in here will go what? Down. Yes? The sensor amplifier will what? Will pick it up. Where is it? Here. Initially, what is it? VDD over 2. Yes? Either you go what? Up or you go what?
Down.
Down. The sensor amplifier will what?
Activate.
Will get it and amplify it to what? 1 or what?
0.
Take it all the way to what? To 0. Yes? And then what does he do? Whatever he is reading,
Yeah.
after he reached the what? Maximum or what? Minimum, VDD 0, he put it on what? He put it on the bit line again. Why? Tell me, why is the content destroyed? Let's assume the content is 0. Yes?
Yep.
When there is a what? When there is a current going this way, the voltage here is no longer what?
0.
0. So you have destroyed the content of the what? Of your cell. Did you get it? Yes?
Yeah.
Oh. I don't remember if we went through the equations, but let's go over it very quickly. What is this one? What is C times V? 240. 240. When you multiply the capacitance by the voltage, what do you get? You get the charge. Yes? What is this? CS, VCS. Yes? What is CS stands for? The cell storage. The cell storage capacitor, which is this one. This one. Yes?
Yeah.
How much is the voltage across it? Multiply by the capacitor. What is this one?
Bit line.
That's the charge on the what?
Bit.
On the bit line capacitor. Yes? Multiplied by what? VDD over 2. That's initial. The initial. Yes?
Yeah.
Can you tell me what is this? Why it is CB plus CS? Because they are connected in parallel. Yes? After the transistor closes, They are connected in parallel. What is this? VDD over 2, which is the pre-charge voltage, plus what? Delta B. Question, could delta B be negative?
Yeah.
Could delta B be positive?
Yes.
Delta B could be negative or it could be what?
Positive.
Positive depending on what is being stored. Okay, you calculate or you evaluate delta B, which is this one. Why is this one true?
Because you have a bunch of.
CB is much greater than CS because CB you are going to take into account all the what? All the cells that are connected to that bit line. Yes?
Yeah.
Remember, by the way, this parasitic, but parasitic of what? Of multiple cells in parallel, not in series, in parallel. Did you get it or not? Why they are in parallel? Can you show me why they are in parallel? This is a bit line. Yes, this is for one cell. This is for another one. Is this one and this one in parallel? They are in parallel. When they are in parallel, the capacitor will begin to what? Will begin to increase. Clear? So why do we need this? So that this CB plus CS can be approximated by what? CB. Oh, by the way, you cannot remove the CS. CS is in the numerator by itself. You cannot say ignore it. You ignore it, you don't have anything left. Did you get it? You can ignore it here, but you cannot ignore it here. And you can see delta B is either what? Negative, when it is negative, when the stored bit is a 0, or it is what? Positive, if the stored bit is a what?
One.
A 1. VDD is more than VDD over 2. Clear?
Yeah.
Then we went, or maybe I forgot. Did we go over this?
Yeah.
Okay. What did we see in the sensor amplifier for DRAM? We have only one bit line, but I need what?
Two.
Differential voltage. So what did we say we do? We divide the what? The bit line. This is the bit line equally to what? Number of cells on the left hand side and the number of cells on the what? Right hand side. We can do that. Why? Because again, as I told you, the size of the memory is usually 2 to the power something, which is divisible by what? By 2. Did you get it? Divisible by 2. So you can do these are the cells that are connected to the left hand side. These are the cells that are connected to the right hand side. Then what did we add? We add 2 dummy cells, only 2. One on the left hand side, one on the right hand side. Clear?
Yep.
If I want to what? If I want to read a cell which is on the left hand side, what do I need to do? I need to activate the what? The dummy cell on the what? Right hand side. But what? I turn this one off. Did you get it or not? So let's see if you can help me. So we created what? 2-bit line. But in reality it's 1-bit line. But since we divided it by 2, we put the sensor amplifier here. Can you tell me what is the purpose of this? That's a pre-charge. I'm going to pre-charge the bit line both sides. VDD over what? 2. Did you get it? VDD. What is the equalization for?
Make sure that they exactly.
Make sure that they are what? They are of the same what? Voltage. How do we do that? I showed it to you in the sensor amplifier and the ECE, which is this one. This one. Did you get it?
Yeah.
Yes or no?
Yes.
Good. We need another one. Can you tell me why? Another one. Another one. This equalization and pre-charge, we need another one. Equalization and pre-charge. For what reason? This is only for the dummy. Did you get it or not? What am I going to do? Pre-charge this dummy to what? VDD over 2, and pre-charge this dummy to what? VDD over 2. You follow me? Okay. And also make sure they are what? They are equal. Now help me. Suppose I want to read this cell. What do I do? This is what? I need to activate what? To activate this one. Notice, by the way, all of these are inactive. You agree? But this one is active. Can you tell me what happened? Remember, this one is what? Is BDD over what? Over 2. What is this one? BDD over 2. Which means what? This one is what? On, but no current. Okay. This side, this one is over. This one, what was it? BDD over 2. And I'm going to select this one. That's the word line. Yes? What happened? This one will go what? Will go ground, or it will go what? Up, depending on what? What is being stored in here. Did you get it or not? If what is stored is a 1, what happened? The current will go this way. This one will increase more than what? VDD over 2. Yes? If it is a what? 0, this one will go down below what? VDD over 2. Clear? This line will remain what? VDD over 2. Why? I'm still waiting. Why it remains VDD over 2? What is this? VDD over 2. What is this? VDD over 2. Is this one on? Yes, it is on. But there will be no what? No current. Why? Because the drain and the source are of the same voltage. Yes or no?
Yes.
Yes or no?
Yes.
The sensor amplifier will what? Will sense the difference in the voltage. This one is going what? Up or down? This one remain what? VDD over 2. Did you get it or not? So the difference between them is either what? Positive or what? Negative. The sensor amplifier will catch it, and then what? We put it on the bit line. Clear to write it again. Did you get it? Yes or no? Oh, now, the next one, I don't have a slide for it, so I'm going to show it to you on the board. Before they came up with this design, it was a 3T. 3T DRAM. Let's see if you can help me understand. There's also a 2T DRAM, but the 2T DRAM, I will leave it till fine. Let me show you the 3T DRAM. Excuse me. All NMOSes, Word line, read line. Are you following me?
Yep.
No response. Are you following me?
Yes.
Oh. No. One more time. Are they connected? Here. No connection.
No connection.
Are you confused?
No.
Should I put the jump or are you not confused? Not confused.
Confused.
Okay, good. And after I describe it to you, by the way, are there two bit lines? Bit line bar, which means what? This one is just like the ESRA. Clear? After I'll explain to you how it works, you need to tell me whether